Hi everyone, welcome to a Primary 6 revision maths class. Today we will be going through a maths prelim paper from Catholic High. This is where I got my paper from sgexam.com. So you can actually come to this website and download the paper for yourself and try it out. Okay, so we'll be doing the prelim paper from 2023. Let's take a look at the questions. I will go through some of the harder questions with you. Okay, let's start with this angles question. So for angles, this is what you need to take note of, okay? You need to take note of words like straight lines. So every time you see a word straight line, two properties need to come into your mind. Okay, let's highlight the word straight lines over here. Straight lines. And if there are two straight lines and the two straight lines are intersecting, that will tell you another property. And as you can see here, there are actually two straight lines. So that will tell you a property that I will tell you later on, okay? Let's start with the first property of straight lines and angles first. The first property will be angles on a straight line add up to 180 degrees, okay? Angles on a straight line add up to 180 degrees. That is the first property that you need to remember when you hear about straight lines. Okay, the second property is the most important one, okay? It is, okay, not the most important one, but it is another property of straight lines. That is intersecting. Okay. It is opposite angles are equal. Okay, so on a straight line, opposite angles are equal. And that only applies if the two lines that are straight lines are intersecting each other. Okay, do we have two lines that are straight lines that are intersecting each other? Yes, we do have, okay? The two lines that are intersecting each other is QR and ST. Those are the two lines that are straight lines that are intersecting each other. So we do have that, and that's why point number 2 should immediately come to your mind. When you see two straight lines crossing over each other, your opposite angles are equal, need to be a property that is most likely going to be used. So let's see which is the two angles. The two angles are the ones in blue. Those are the two opposite angles that are equal. Now let's try to make use of point number 1 to find one of the angles. Point number 1 is angles on a straight line add up to 180 degrees. Do you see here QR? Okay, QR has a few angles on it that can be used to add up to 180 degrees. And what you can do is you take 180 degrees minus away, okay, 180, oops. 180 degrees minus 106 degrees minus 27 degrees. That will give you the blue angle, which is 47 degrees. Yeah, and because the 47 degrees is the same as its opposite angle, let's write down the same degree on the opposite side. Now we have all the angles except for angle N. And as you can see, all the angles are around a point in the middle, right? This something that looks like this should immediately remind you, but there are a lot of angles, okay? It should immediately remind you of angles at a point, okay? I'm going to show you the point again. You see the blue color thing in the middle? Yeah, this blue is a point. So if you see a lot of angles surrounding a point, that means that you need to use angles at a point. So angles at a point, the property is angles at a point. Okay, let's look at property number 3. Angles at a point add up to 360 degrees. Okay, so let's make use of this property. So 360 degrees, we have all the other angles in the point. We can take 360 minus all angles that we have around the point except for M. And if you minus all the other angles, you will be left with only M. So that is what you're looking for. So let's do that. Okay, 360 minus 47 minus 106 minus 27 minus 47, and here there's 90 degrees, so minus 90 degrees. And you will get you will get 43 degrees. So this 43 degrees is your answer, okay? So as you can see, there's an option that says 43 degrees, so the answer is number 3. Okay, let's move on. Okay, let's take a look at this question on fractions, okay? What this question is talking about is, let's highlight the question first. Walter packs 4/5 kg. Okay, when you see 4/5 kg, the fraction is a number. Okay, the number is the kg. So it's not a fraction of the flour, it is a fraction of 1 kg. Okay, that's why it's 4/5 of a kg. Yeah. So if you see a fraction of something, it means it is a fraction. But if it is a fraction with a unit behind, like a fraction kg, it means it's a fraction of the kg. So this is actually 4/5 kg, not 4/5 of the flour, if you get what I mean, okay? Yeah, so over here, let me write an arrow. This means 4/5 kg, 4/5 of 1 kg. Yeah, so this is a measurement. It is an amount. It is an actual number. It is not a fraction. You treat it as a number. It is a fraction, but you don't treat it as a fraction of the flour. You treat it as a number, how heavy the flour is, basically. Okay, this is how heavy the flour is. Okay, these numbers here are how heavy the flour is. Okay, that includes this other number here, which is it was packed into bags of 1/4 kg. Yeah, so that is the second thing. So what Walter did is he took 4/5 flour. He took 4/5 kg of flour and he packed it into. Okay, so imagine the flour is this heavy, okay, 4/5 kg. And he packed it into many bags, okay? So this is a division question. Yeah, you are splitting them up. So splitting up means division. And each group, okay, inside of each bag, he put 1/4 kg. But you don't know how many bags he has. Okay, so what you need to do is you need to divide, and you need to take the total divided by what is in the bag. The total is this thing on top. He had 4/5 kg. And the each, which is inside of the, how many is inside of one group, is 1/4 kg. So you need to take the total divided by the each to get how many groups there are. Okay, groups. You don't know the groups. Okay, so let's do that. Let's take 4/5 divided by 1/4. And when you are dividing a fraction, you must remember to change it into a multiplication and flip the fraction. Okay, so you need to flip the second fraction, the 1/4. So let's do that. Let's change it into a multiplication. So 4/5 becomes times 4/1 equals to, okay, you see I flipped the 1/4 I flip the 1/4 into a 4/1, okay? So this flipping, you need to change the sign from divide into times as well. Remember to change the sign, okay? You must change it into a times. Okay, now let us solve it. So 4 times 4 is 16/5. Then you must change it into a mixed fraction, which is 3/1/5. Okay, as you can see, it is a 3/1/5 bags of flour, okay? It's 3/1/5 bags of flour. So basically, you can pack it into 3 full bags, but will be left with, you can pack into 3 full bags, but you will be left with 1/5 bag. This is 1/5 bag, okay? Not 1/5 not 1/5 kg. Alright, this is a 1/5 of a bag, not 1/5 kg, yeah? That's why I'm trying to tell you the difference, okay? 1/5 bag. So what you can do is you can figure out what is how many flour is in 3 bags, and then you can minus it from there. So what you need to do is, okay, let me just erase this one in front first. Okay, so you see your units are super important, because if it was 1/5 kg over here, okay? If this is 1/5 kg, then you can immediately put your answer as 1/5 kg. But it is not 1/5 kg because this is 1/5 of a bag. You did here, you divided by 1/4. It tells you how many bags there are. Bags are the number of groups, okay? Division will tell you how many groups there are. So how many bags there are. But this is not the number of kg that is. It is a number of, it's a fraction of a bag. So it means that the 1/5 is a 1/5 of the bag. Inside of one bag is 1/4 kg, okay? Okay, look here. So as you can see, the 1/4 kg over here that I'm underlining, yeah, that is how many there is in one bag. So you must find what is 1/5 of 1/4 kg. That will tell you what the mass of the flour left is. Okay, so there's 2 ways to do it. Let's do the first way first. First way is what is 1/5 of the 1/4 kg, okay? So 1/5 of a bag is the same as, because one bag has 1/4, right? So it's the same as 1/5 of 1/4 kg. Okay, because 1/4 kg is the bag. Alright? It's the amount in each bag, okay? So anything that is off is a time. So 1/5 times 1/4 kg. So that is 1/20 kg. So that is your answers. This is the first way, okay? Which is understanding that 1/5, this is 1/5 of a bag, and in each bag there is 1/4 kg. So 1/5 of a bag is the same as 1/5 of 1/4 kg, which is 1/5 times 1/4 kg, because anything that is off means it's a multiplication. So in the end, you get 1/20 kg. Let's look at the second way to do this. The second way to do this is basically to find what is how much he put into the bags, okay? So let's say we want to use the number 3 instead. Okay, do you see this number 3 here? Okay, we want to use that instead. So how do we use that? We can take 3 times 1/4 kg, because again, okay, 1/4 kg is the amount in each bag, okay? And there were 3 bags. Yeah, there were 3 bags that we can put it in. So we must find out how many we put in first. So we put in 1/4 times 3 times 1/4, which is 3/1 times 1/4 is 3/4. Okay, so in each, so he put in 3/4 kg. So what is left will be the total, okay, 4/5 minus 3/4, which equals to times 4 times 4 times 5 times 5, which is 16 over 20 minus 15 over 20, which gives you 1 over 20. Do you see that we get the same answer? It is 1 over 20 that is left. So 1 over 20 is your answer, okay? So this is your second method. Your second method is firstly find how many did he put in. Okay, how do you find how many he put in? You take the number of bags, which is 3, times the number of kg in each bag, which is 1/4 kg. Then you solve it, you get 3/4. Then you take the initial total, okay? As you can see, the total is over here. You take the initial total minus away what he put in, which is a 3/4. And then you solve it, you get 1 over 20. 1 over 20 will be what is left. Yeah, because you took the total minus what he put in. You took the total minus put in. So this answer here is equals to left. Okay, so that is your answer. Your answer is number 3, which is 1 over 20 kg. So this is important, okay? You need to understand the difference between a fraction that is a kg versus a fraction that is a fraction of something, okay? So again, if you see here, this is 1/4 kg. That is 1/4 of 1 kg, not 1/4 of the flour. Sorry, this is 4/5 of a kg, not 4/5 of the flour. So you need to treat this as a constant, as a number, not as a fraction. All right? Meanwhile, the thing at the bottom over here, the 1/5 of a bag, that is a fraction. That is a fraction of the bag. So it is 1/5 of a bag. Okay, so the bottom one, you must treat it as a fraction of the bag. But on top this one, okay, this is a fraction of the kg. So if you see any measurement behind the fraction, it is not treated as a fraction, it is treated as a number. Like for example, 4/5 cm, okay, this is not 4/5 cm in a ruler. This is not 4/5 of a ruler. This is 4/5 of the cm. Okay, 4/5 of 1 cm. So it is a measurement that is like much lesser than 1 cm, but it is not a fraction of the ruler. Okay, I hope you get what I mean. I'm going to move on. Okay, next one. Jean had some tickets to sell. After selling 5-6 of them in the morning and 4-7 of the remainder in the afternoon, she was left with 1/5 of the tickets. How many tickets were sold altogether? Okay, so she sold 56 of them in the morning and 4-7 in the afternoon. And she is left with 1/5 of the tickets. Okay, so this one, the most important thing here is this word of the remainder. So whenever you see 4/7 of the remainder, it means that when there's of the remainder, you have to do a branching method, okay? You need to do level by level. So what you can do is, first, you find out what is the amount that... Okay, let's draw a branch first, okay? So at the start, she had some tickets. Some tickets. Then after that, she sold 56 of them in the morning. Okay, and then she'll be left with some. But you don't know what is the fraction that she's left with. So let's not write, you don't know the number she's left with. So let's not write that number yet. Next, you have 4/7 of the remainder. So the remainder is what is left, right? So you put 4/7. So it's your next branch already. Okay, 4/7 of the remainder. So the left, you must put 4/7. That is how much she sold in the afternoon. Okay, afternoon. This is morning. Okay, so 4/7 in the afternoon. Then, after she did that, she was left with 1/5 of the tickets. Okay, so 1/5 over here is left. Now let me just shift it over. Let me shift my diagram. Okay, I draw again. Then you follow me using my highlighter. Okay, so the first one is sell 56 of them in the morning. So let's draw that. Oh, I guess it crashed. Okay, let's go back to the question. Where's the question? Okay, over here. Okay, so let us start with the first line. The first line is 56 in the morning. Okay, so 56 in the morning. So let's write that down. 56. Okay, let's start with the first one first. Some tickets to sell. Some tickets. So let's start with the some tickets she had, which is some tickets, okay? And then next one is she sold 56 of them. So 56 sold. And that was in the morning. And you don't know how many she's left in the morning, okay? Left morning, you don't know. But you know that she sold 4/7 of that. 4/7 of the remaining, okay, which is the left. 4/7 of the remainder. So remember, anytime you see the word a fraction of the remainder, like 4/7 of the remainder, you need to draw the branch, okay? Because this is a level thing. At first, she sold this, then a fraction of the remainder is a second level. Like over here, you see the 4/7, that is the second level of the branch. So every time you see of the remainder, you must draw a branch to help you understand better about which level you are working on right now. Okay, so let's continue. After you draw 4/7 of the remainder, that is the amount that she sold, which means that what she is left with is 3/7 left. Okay, then now let's look at the third sentence. The third sentence will give you a hint on how to answer the question. Usually the third sentence is very important, okay? So the third sentence says that she was left with 1/5 of the tickets. Do you see the 1/5 is of the tickets? That means that, okay, 1/5 of the tickets. The tickets is the number of tickets she had at the start, okay? This is not the remainder. It's not 1/5 of the remainder. It was 1/5 of the tickets. So this means that you need to link it back all the way to the start here, okay? Where it is some tickets, okay? You must link here. Right, how do you link that? Firstly, you need to know that the left in the afternoon is the 3/7. Okay, 3/7 is the left in the afternoon. So you need to work with the 3/7 over here, which is the left in the afternoon. Then you must link the 3/7 to the 1/5 because the 1/5 is the starting amount of tickets, right? It's the 1/5 of the tickets. Of the tickets means it's the start. where is the number of tickets she has, okay? It's not the remainder of the tickets, it is the start, where there is some tickets, okay? Here. All right. So let me erase that stuff and then continue. Okay, so 3 out of 7 left in the afternoon. That is the same as 1/5 of the tickets. All right, so you need to link that this 3 out of 7 is the same as 1/5 of this one. Okay, 1/5 of the tickets. So what you need to find is that how many. Let's look at the question. Okay, how many tickets were sold all together. So what I need to find is the 56 plus the 4 out of 7 sold. Okay, and do you see the question mark here? This question mark is most likely what you need to find in order to solve the question. Because you don't have that. Usually if there's a missing piece of information, that is what you need to find. So let's try to find the question mark using the two fractions, 3 out of 7 of the left afternoon and the 1/5 of the stickers. So basically what this means is that 1/5 of the stickers is 3 out of 7 of the afternoon, left afternoon. Okay, let me just erase these things here first. Okay, 1/5 of the stickers stickers at the start, okay? So let's just write 1/5 stickers start equals to 3 out of 7 left afternoon. So if you look at the two fractions, what you can see is that if you want to find the other one, which is the sold afternoon, because you see, you need to find the thing that you're trying to find is the left morning, right? The left morning. That is the question mark that you're trying to find. So if let's say 1/5 of the stickers at the start is the same as 3 out of 7 of the left afternoon, you need to find what is the fraction at the start that is the 4 out of 7, okay? I will explain, you will understand why later on. Okay, first let's look at this. So, okay, so again, look at my arrow that I'm drawing. 3 out of 7 is 1/5 of the stickers. You need to find 4 out of 7 is what fraction of the stickers. Okay, how do you do that? Okay, let's say 1/5 is 3 out of 7 left in the afternoon, right? What you can do is you can take 1/5 divided by 3, okay? That will give you 1/7 of the left stickers. So 1/5 divided by 3 is basically equals to, okay, because I don't really have enough space to write here, I'm going to not do the division. I'm going to just like not expand the division and do it without a calculator, but you guys need to do it without a calculator, okay? Okay, so 1/5 divided by 3 is 1/15. So this 1/15, right? Okay, why did I divide by 3? Because why did I divide by 3? Because you see here is 3, right? I'm trying to find 1 out of 7 first. So this is actually 1 out of 7. Oops. This 1/5 is actually 1 out of 7 of the left of the 1 out of 7 of the afternoon, okay? Because the afternoon has 7 units, yeah? Okay, let's look back here, okay? The afternoon has 7 units in total. So let's us try to find what is 7 units and what is the left. Okay, if you find all the 7 units here, you see here got 7 units, here got 7 units. If you find all the 7 units, you will actually just get the total, which is the left morning. So that is what we're trying to find. So we're just trying to find 7 units. So now we got the 1 out of 7. Let's find the 7 out of 7. So the 7 out of 7, okay, is the same as 1 over 15 times 7, okay? Because 1 out of 7 is 1 out of 15. So 7 out of 7 is 1/15 times 7. So that is 7 out of 15. So your 7 out of 15 will be your left morning, okay? 7 out of 15. So now you have your left morning fraction, which is 7 out of 15. You can find what is the other side. Okay, so if the right side is 7 out of 15 is the left side, which is the slope, will be 8 out of 15. So if 8 out of 15 equals to 56, 7 out of 15 will equal to... Okay, let me just erase. I'm going to erase some of my working, okay? You can pause and go back if you didn't manage to catch it, okay? So now we've got this 2 over here, which is we've got the 8 out of 15. We've got the 8 out of 15 and the 7 out of 15. Right? So we know that 8 out of 15 is equals to 56. So here, 56. So you want to find what is 7 out of 15. This is what you do, okay? Okay, so 56 equals to 8 out of 15. So 1 out of 15 of the ticket, okay, this is tickets, So 1 out of 15 of the tickets is equals to 56 divided by 8, which is the same as 7, equals to 1 of 15 tickets. Okay, so now you need to find what is 15 out of 15 tickets, which is the total, which is the original, right? 15 out of 15. Okay, let me just... Okay, why do we need to find 15 out of 15? Because you see the total is, at the start is 15 out of 15. That is 1. We always start with 1, yeah? So let me just move it down here, okay? So 1 out of 15 equals to 7, which we did just now already. 1 out of 15 tickets. Okay, must make sure you write in the tickets, so you know this is a different thing, okay? Tickets equals to 7. So that means that you need to find 15 out of 15 tickets, which equals to 7 times 15, which gives you 105. So the answer is 105. Hey, sorry. Okay, okay, it's not 105, sorry. 105 is the total. You need to find the SOL. Okay, so what you need to do is actually not find the total, okay, not find 7 out of 15. You need to find the left morning first, okay? You see here? Oh. Okay. Okay, let's look back on top, right? You see the thing I'm coloring here? I know it's blocking the word, but it's this one, okay? This 7 out of 15 will give you the left morning. So you need to find 7 out of 15 is how many tickets? Okay, so 1 out of 15 is 7 tickets, okay? Okay, this is start tickets. Okay, it's 15 of the start. 1 out of 15 of the start tickets. It goes to 7 tickets. So what you need to do is you need to find what is the left morning first. Okay, left morning. Okay, this looks kind of complicated, but yeah, you just try to follow along. Okay, so left morning is 7 out of 15, which you need to find what is 7 out of 15. Okay, so 7 out of 15 of the start tickets equals to 7 times 7, yeah, which equals to 49 tickets. So now you can put in your question mark here. Okay, your question mark here is 49. Yeah, I'm over here, yeah. I'm all the way up here. Okay, here. Yes, okay. So the question mark here will be 49. Yeah, 49. So 49, right, is your total left in the morning, is your remainder. So what you need to do is you need to find how many tickets is the 4 out of 7 here, okay? How many tickets is this 4 out of 7? So after you find out how many tickets is 4 out of 7, you can find out how many tickets he sold. So you take 49 times 4 out of 7 to find out what is 4 out of 7 of the 49. Okay, equals to 28. Okay, so there is 28 sold in the afternoon, okay? So this in the afternoon is your 28. So total sold will be the 56 over here plus this 28. Oh. Okay, the total sold will be the 56 plus the 28. So 56 plus 28. Total will be 84. So the answer is 84 for this question. Okay, let's look at the next one. Next one is a percentage question. Okay, the first part of the question says after a 20% discount, the price of a t-shirt was $40. A first-time customer was given a further discount of $6. What was the total percentage discount given to a first-time customer for the t-shirt? So we're looking at first-time customers. This whole question is all talking about first-time customers. So don't need to worry about the first-time customer word too much. Let's look at it sentence by sentence, okay? So the first one, after a 20% discount, the price of a t-shirt was $40. So $40 is after discount, which means $40 is your 80%, okay? Then next, a first-time customer given a further discount of $6, which means that your $40 minus $6, okay? That is the amount that the new customer pays, which is $34. Okay, the next part of the question. What is the total percentage discount given to a first-time customer? So now you need to find a total percentage discount. What does total percentage discount mean? Yeah, what does this mean? Total percentage discount. It means a percentage discount of the final price as a percentage of the original price. So what we need to do is, okay, we need to find the original price first in order to find what is the percentage discount from the original price given to the first-time customer. So let us first look at the original price. Okay, if 40% is the same as 80%, $40 is the same as 80%, if you take 40 divided by 80 times 100, that will give you 100%, okay? 100 equals to, oh sorry, not 100%, just times 100 can already, I think. Okay, times 100 equals to, so 40 divided by 80 times 100. That gives you 50, okay? So $50 is the original price. $50 is the original price. You need to find what is the total discount of the original price. So what you can do is that you can first find out what is this discount here. Okay, how much discount did this person get? in order to pay $40. So the first discount given is 50, which is the original price, minus $40. The first discount given was $10. Okay, the second discount given is this $6, yeah? So the $10 and the $6 together is all the discounts. So now you need to find all the $10 and $6, the discounts. What is it as a percentage of the original price? So this is what we can do. Okay, you need to first add the two discounts together. Okay, add the $10 discount and the $6 discount together. The total discount given to the first time customer is $16. And now you need to put $16 as a fraction of the original price. That will give you the percentage discount. Okay, remember fraction and percentage are the same thing. Okay, they are very similar. Fraction, percentage, and ratio are all the same thing. So you can actually put 16 out of 50, okay? Where did I get the 50 from? I got the 50 from the original price, okay? Because we want to put the discount as a fraction of the original price. So I put the discount as a fraction of the original price here. I get 16 out of 50. This 16 out of 50, you need to simplify it and it will give you the percentage discount. Okay, it will give you a total percentage discount. Why? Because it gives you a percentage of the total that the amount of discount given is. Okay, the amount of discount, all the total amount of money discounted is $16, right? Total amount of money discounted, $16. Then you need to use the total amount of money discounted and put it as a fraction of the original price. This will tell you the fraction discount given. The fraction discount given is the same as the percentage given because remember 80%, okay? If you remember, 80% is the same as 80 out of 100. So if you have this over here, which is 16 out of 50, what you can do is that you can simplify the fraction. And because a fraction of because 80% is where the total is 100, right? And then the number that we are looking at is 80. So it's the same as this 16 out of 50, okay? The number we're looking at is 16, the total is 50. So just by using the fraction itself, that is already a percentage of the entire thing. So let's simplify 16 out of 50, okay? 16 out of 50, simplify already, you will get okay, so 16 out of 50, you still need to times 100, okay? So in order to convert it into percentage, you must take the fraction times 100%. And you don't key in the percentage, you just take 16 out of 50 times 100. Keep the percentage only as a unit. So 16 out of 50 times 100 will be 32. And then this percentage, don't add it in, okay? Just put it as a unit, okay? So 16 out of 50 times 100 is 32. So it's 32%. So that is the answer, which is number 3. Oops. Okay. Let's move on to the next question. Remember, if you don't understand, please rewind and watch again. Okay, next one. This one is a ratio question. So in a ratio question, what you need to do is you need to look at what type of question might it be. As you can see over here, there are two ratios and there is a shape. So most likely you have to do equivalent ratios, which is to make one of the ratios the same. Okay, so let's look at the options that we have. Okay, the first sentence is ABCD is a rectangle made up of 4 triangles. Next one is the ratio of triangle ABF to that of the rectangle is 1:9. So let us use our highlighter to look at what is ABF. Okay, ABF is this one. So ABF is 1 and the rectangle, which is the big one, is 9. So every time we see something, we need to write it down. So let's write down the first ratio, which is ABF is to rectangle is 1:9. Next one, AFE is to rectangle is 1:6. Okay, that's the next sentence. Yeah. Okay, let's just erase this so we can use the diagram. Okay, so now we need to look at 3 different statements. The first statement is the ratio of triangle. Okay, you need to see which one is true, okay? Let's just highlight that. Which one is true? The first one, the ratio of triangle ABF is to AFE is 2:3. Okay, so in order to find out if this statement is true, you need to firstly make the two ratios up here comparable. How do you make it comparable? You need to multiply to make something the same. So you need to observe what is the same in these two ratios. Okay, the thing that is the same is the R and the R. So let's make the R the same by multiplying the ratios. So 9 and 6, how do you make them the same? Okay, you times both of the numbers in the ratio by each other. Wait, actually, you may not have to times it by each other because okay, you may not have to times it by each other because they are both multiples of 3. Yeah, so you can just find the lowest common multiple of 9 and 6. So lowest common multiple of 9 and 6, 9, 18, 6, 12, 18, okay? Lowest common multiple is 18. So actually you just need to take this 6 times 3 and then the 9 times 2. Okay, so let's do times 2 here for the first one. The next ratio will be 2:18. And then the bottom one, you just times 3 times 3. The next ratio will be 3:18. So as you can see, the R, we have made both of the R's into 18. So this is the equivalent ratio. Then we can continue and see whether we can compare it that way, okay? So let's look back at the statement. The ratio of ABF is to AFE is 2:3. Is that right? Okay. That is right, okay? The ratio is 2:3 because you see here, 2:3, that is ABF is to AFE. So the first statement is correct, okay? Correct. Okay, next one. ED is the base of triangle EFD. Base, yeah, of the EFD. And the height is EF. Okay, ED is the base. Let's look at it. Where is EFD? EFD is here. Is ED the base of EFD? Looks like it might be the base of EFD, right? Because it is at the bottom. It looks like it's at the bottom of the triangle. So this part may be correct, okay? Maybe. But then the second part, where it says its corresponding height is EF. You see the EF, right? Does it look like a right angle to you? Did they say anything about it being a right angle? No, nothing is being said that it's a right angle, so you cannot assume that it is a height, okay? The height of a triangle must always be at a right angle from the base. Okay, you see this that I just drew? The height must always be at a right angle from the base. But there is nothing to say that there is a right angle between the height and the base, okay? Over here is a random angle. Yeah, over here is a random angle. It's not, they never say it's a right angle, so you cannot assume it's a right angle. This one is not correct. Okay, let's look at the last one. The sum of the area of the triangles ABF and DEC are equal to the sum of the area of the triangle. Okay, so basically what I'm saying is ABF is the same as, okay, ABF and DEC is the same as AFE and EFD. Is that true? Let's underline. Okay, I'm going to use a different color for AFE and EFD, okay? Okay, so let's do blue for ABF and DEFC and green for AFE and EFD. And we see whether they are equal. Okay, so let me erase all the highlights here first and use this highlighter. Blue, ABF. And then DFC. Okay. And the next two is the AFE and EFD. AFE, yeah, and EFD. So they're asking us, is it exactly half of the rectangle? Is the areas half of the rectangle? Okay, so what you need to do is actually look at the height and the base of the triangle. Okay, let me just simplify this, okay? Okay, the first, oh, wow. The first one is AFB, that is your first triangle. Okay, and this triangle is DCF. Okay, so this is the first part. Let's identify the height and the base of the first part. Because the area of a triangle is half times base times height, correct? Area of triangle is half, oops. Half times base times height. So because half will always be the same, okay? All the area you have to use the number half. So the thing that is different is your base and your height. So you need to see, are the bases and the height the same? If they are the same, then they will be equal. If they're not the same, they won't be equal. Okay, so let's check. Is the base and the height the same? The first set, which is ABF and FDC, the base is the side of the rectangle. That is their base, okay? Their base add together become the side of the rectangle. Their height is the same because it reach from one end to the rectangle to the other end. Their height is over here, okay? So their base is at the side, their height is over here. Let me just erase the side thing, sorry. Okay. So their base is, when add together, okay? Okay, I'll show you. Oh. Okay, their base, right, is this part plus this part, which is basically the same as the side of the rectangle. So this is their, oh sorry, this is their height. This is their base. Yeah, this is their base. This is their base. And their height is this part. Okay, both of them have the same height, which is here. Height. So their base is bottom of the triangle, is the side of the triangle. Their height is the entire bottom of the right. Their base is the entire side of the rectangle. Their height is the entire side of the rectangle. So take note of that, okay? Now let's look at the, okay. So let's write that down first. This one is the base is the side of the rectangle of R. Okay, R is a rectangle. The height is the base of rectangle. Yeah? Now let's see the second one. What is the base and the height? Okay, the second one is the sum of the area of triangle AFE and EFD. So let's highlight that with green. That one is this one. Oops. That one is this one, okay? This is the next one. This is AFE and EFD. Okay, so it looks like that. So let's look at the base of these two triangles first. Okay, this is the first triangle, this is the second triangle. So the first triangle, the base is AE, and the second triangle, the base is ED. Do you realize that the two of these add up is also the entire side of the rectangle? Okay, and what about their height? Their height, you see, both the rectangle reach from the bottom all the way to the top of the rectangle. So their height is also the same, which is the bottom or the base, okay? Let's just write base. Base of rectangle. Okay, so let's see, is it the same? The side of R? Yes, okay. Base is the side of R, side of the rectangle. The height of the triangles are the base of the rectangles. Both of them share the same base and the same height. Yeah, so if they share the same base and the same height, that means this statement is correct. ABF and DFC is equal. Why? Again, because as you can see on the screen, AFE and EFD have the same side, which when you add their sides together, it is the side of the rectangle. And AFE and EFD, the green color triangle, the height of these two triangles are the base of the rectangle, which is the same as what we saw just now in the first pair. In the first pair, ABF, in the blue triangle, ABF and DFC, it is the same, okay? Their height and their bases are the same. So if their heights and their bases are the same, their area will be the same because the area of a triangle is half times base times height. The half is always the same. So you only need to make sure that their base and their height are the same. And since the base and the height for both pairs are the same, the last statement is correct, okay? So in this case, the answer will be A and C only. Okay, A and C, because B is wrong. So A and C. Okay, let's continue. Oops. I think I will do one final question today. Okay, let's look at the next two questions. I think I will do two questions. Okay, let's look at this first question. Okay, this one is ratio question. So the first part says that Nathan had 92 and Mabel had $50. Each of them bought a book at the same price. So the second sentence already you need to write down a ratio. The ratio is 1:1. Okay, same price, 1:1. So N is to Mabel. How much did they buy the book for? Same price, 1:1. Okay. Next one, the ratio of the amount of money Nathan and Mabel had left is 5:2. So over here you already have two ratios. So when you have two ratios, what you need to think about is this thing called equivalent ratios. Okay, equivalent ratios. So when you have two ratios, think about equivalent ratios. Let's try to use that to solve this method, to solve this this question. So don't look at the numbers first, the $92 and $50. Don't look at that first. That is for you to solve after you have the equivalent ratio. So this is, you must write what ratio are you writing, okay? This is bot. Bot is Nathan is to Mabel is 1:1. Next one is the left. Okay, left, let's underline that. Left is 5:2. Left N is to M is 5:2. Okay, now that you have two ratios, you've got the bot and you've got the left. What you need to do is to see whether the fractions are equivalent. So the bot N and the bot M is 1 and 1. And the left N and the left M is 5 and 2. So if you look at it, okay, I can see another way to do it very without having to do ratio. The other way to do it is just because they bought the same amount of money, right? So that means that this 1:1 is the same. And that any difference in this is caused by the difference that they had in the start. Okay, this is the observation that I have, which is that because they spend the same amount of money, any difference that they have at the end is the same as the difference they had at the start, if you get what I mean. Yeah. So actually this is a very like observational question, which is that because 1:1 is the same amount of money, right? But then 5:2 is different. So how did this difference come about? How did this difference come about? Okay, this difference in ratio. How is that? How did it go from 1:1:5? It become into 5:2. It's because at the start there is a difference in the first place. Okay, so at the start, now you have to write a ratio for the start as well. So start, okay, N is 2M. You can actually make a ratio for the start. Do you know that? Okay, the ratio at the start is 92:50. Okay, is 92:50. So what you can see is after 92:50, you minus 1 minus 1. What you were left with is 5:2. Okay, this is 1 unit, okay? Minus 1 unit, minus 1 unit. The 1 units are the same amount of money, right? So that means you don't have to think about equivalent ratio actually. You can just use your observation. So because the 1 unit and the 1 unit is the same amount of money, that means that any difference in the remaining amount is basically the difference that they had in the start. Okay, so if you see here, the difference in the remaining ratio is 3 units, okay? 3 units different. That is basically the difference in the amount that they had at the start, which you have to take $92 minus 50. That gives you $42. And this $42 is basically the difference at the end, because the difference at the start and the difference at the end will be the same because they minus the same amount of money. Okay, so 42 will be your 3 units. So you want to find how much the book cost at the start, right? I mean, how much the book cost, right? You need to find the amount that they used to buy it. So the amount they used to buy it is basically the difference between the start and the left. Okay, so okay, let me just erase this first. Okay. So anyways, let's just use the observation, okay, first. Let me just rewrite this thing for you so that it's clearer. Okay, so you must have the start ratio as well. So start N is to start M is 92 is to $50. Okay. Then next is the bot. So bot N is to bot M is 1 is to 1. Then the final or the left, okay. Left N is to left. M is basically 5 is to 2. So what we did is, because the amount spent is the same, we needed to find what is the amount spent. We can easily find what is the amount spent by finding the difference between 5 is to 2. That will be the same as the difference between the start, which is 92 and 50. So let's do the difference first. So the difference, okay, is $92 minus $50, which is $42. That is your difference. And your difference is over here, the difference is 3 units. So 3 units equals to $42. So 1 unit equals to $14. Okay, so this $14 is the 1 unit of this ratio over here. So let's use that ratio, okay? The ratio we want to find, let's use, you can use either 2 or you can use 5. Let's use the 2. Never mind, let's use a 5, okay? So we're going to use this 5. Let's find how much is this 5 units, okay? So 5 units is 14 times 5, which is 70. Okay, so the 5 units, which is the left end, right? As you can see the left end here, which is the 5 units, yeah? So the $70 is the left end. Now we need to find the difference between the start end and the left end to get the how much he used to buy, how much money he used to buy. So start M, okay, which is up there, $92. So you take $92 minus the left end, how much he left in the end. So minus the $70 here. Okay, $70 equals to 92 minus 70. $22. So the book cost $22, okay? Because you see, I took the start minus the left, that will give you how much she spent, right? $22 is how much she spent. So that is the answer. Okay, let's move on to the next one. Next one is ABCD is a rhombus and DEFG is a square. Okay, so when the moment you hear the word rhombus, you must write in the properties of a rhombus. Okay, let's underline rhombus and square. So let's write in the properties of a rhombus, because when you hear rhombus, you must do that, okay? So rhombus, all sides are equal. So let's write in the all sides are equal. Okay, how about square? Square, what properties do you have? All sides are equal and all sides are 90 degrees, okay? Okay, square all sides are equal, you must put 2 lines now because they're different shape, okay? And all sides are 90 degrees. Okay, so let's look at how we might be able to find FHD. Okay, where is angle FHD? FHD is over here. I'm going to highlight the angle, okay? FHD. This is the angle you're trying to find. Yeah, so let's take a look at how we might find it. We are given 2 angles. The 2 angles we are given is the 75 degrees and the 260 degrees. So make sure you use all the angles that they give you, because most likely there's a reason why the angles are there. So let's look at the 75 degrees first. Can we use the 75 degrees? How can we use the 75 degrees? Well, actually, the rhombus has a property, okay? The property of the rhombus is that all opposite angles, okay? Like diagonally opposite, okay? Like this, diagonally opposite. All diagonally opposite angles in a rhombus are equal. Let me write down the property. All opposite angle in rhombus are equal. Okay, it's not opposite, it's diagonally opposite, okay, diagonally. So as you can see here, this is the diagonal. So the angle over here, yeah, this part here, this angle will be 75 degrees. Okay, that angle is 75 degrees. Then you see the 75 degrees, it overlaps with the right angle over here. Okay, of the square. So the 75 degrees overlap with the right angle. And then the second thing is, if you see okay, the second thing is you can most likely find what is the angle by using 260 degrees minus 360, right? To find the angle in green. This one, you can find the angle in green. So the angle in green will be 360 minus 260. Yeah, then now you need to find what is the angle inside of this entire thing. So actually you have three possible angles you can find. One is the 90 degrees, one is the green one, and one is the red one. Let me just clear up the diagram so it's not too messy, okay? Okay, I would suggest we find the simplest angle we can find first, which is this green one over here, okay? So that one is 360 minus 260, which is 100 degrees. So here is 100 degrees. Okay, next, if you realize that one is 100 degrees, right? But you can actually use the right angle inside of the square to minus off the right angle, okay? So let's do that. Oh, okay. So what we can do is we take 100 degrees, minus away the right angle, which is 90 degrees, gives you 10 degrees. 10 degrees. Okay, where is your 10 degrees? Your 10 degrees is over here. Okay, you see I draw and write 10 degrees. 10 degrees is a really tiny angle at the side. Okay, why? Because we took the 100 degrees, which was the green one. Yeah, we took 100, which is the green one, minus away the 90 degrees, which is the square over here, the blue color thing that I'm drawing, okay? We took the 100 degrees minus away the perpendicular side, which is the blue color thing, to get the 10, which is what is the difference between the two of them. Yeah, the difference is 10. Okay, so the 10 is a really tiny angle at the side there. So that is one we can find. Let's see what else we might be able to find. Okay, so in order to find the thing at the bottom here, yeah? Okay, in order to find this, what comes to my mind immediately is this shape over here looks like this shape over here, okay, which the angle is sitting on, which this angle is sitting on, looks like a trapezium. So I have to most likely use the properties of a trapezium, right? Okay, because that is what the angle I'm trying to find is sitting on, a trapezium. So in a trapezium, the first property that comes to my mind is parallel sides, okay? Trapezium has parallel sides. That's the only thing we can use in a trapezium. So let us draw the parallel sides in first, okay? So most likely we have to use 180 degrees minus this angle over here, the one in blue. Okay, this angle. 180 minus this angle to get the angle at the bottom. That is most likely the last step that we have to do. So we need to work towards that step. Okay, so this is done by observing the diagram. You see a trapezium right next to the where the angle is in. Maybe it is a trapezium, okay? So you have to think about the fact that it's a trapezium and you most likely have to find the blue angle minus 180 minus the blue angle to get the angle at the bottom. Okay, so how do we find the angle? First, we already found a small little angle. Secondly, do you remember what I said? Okay, I said that all diagonal opposites, where is it? Let me highlight it. Okay, all diagonal opposite angles in a rhombus are equal. So let's put in that one. That one is this 75 is equal to the over here 75. 75, okay? Okay, let's write in the 75 here. So this one is, which is, okay, you must see this is the corner of the rhombus. So this corner is your 75. Now do you see you can actually take something minus something to get that corner that we were trying to find? The blue corner that we're trying to find over here. You can take 75 minus the 10 to get the small little blue corner. Yeah, so let's do that, okay? So 75 degrees minus 10 degrees gives you 65. So 65 is your blue corner over here, okay? So let's erase everything else first, so it's not so messy. So we already found the blue corner. This blue corner is 65 degrees. So now you have to make use of your rhombus, the last step that I told you to do, which is use the parallel sides in a trapezium, sorry. Use the parallel sides in the trapezium, your last step. So the last property is opposite angles of parallel lines add up to 180 degrees. Okay, so here got two pairs of parallel lines. So the angles between them, the 65 and this angle will add up to 180 degrees. So in order to find this one, you just take 100, in order to find the angle you're looking for, which is this, you just take, okay, 180 degrees minus away your 65 degrees. That will give you your answer, which is 115 degrees. So this one is 115 degrees. Okay, I hope that helped, and I will see you next time. That's it for this session. Have a good day. Goodbye, everybody.